Chapter of Dynamic Thought, or the Law of Vibrant Energy, by William Walker Atkinson. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Substance and Beyond. Science has ascribed to Substance certain characteristic qualities which it calls properties. It divides these properties into two classes, viz. 1. Molecular properties, sometimes called physical properties, and 2. Atomic properties, sometimes called chemical properties. Molecular properties are those which may be manifested by Substance without disturbing the molecules, and consequently without affecting the kind of Substance. Atomic properties are those which concern the atoms when free from molecular combination, and which consequently cannot be manifested without changing the kind of Substance. Science, before long, is likely to add a third class of properties, namely, corpuscular properties, relating to the corpuscles or particles of radiant matter, but so far it has not had the opportunity to sufficiently observe these qualities, except in a general way. There are certain general properties that seem possessed by both mass, molecules, and atoms, and probably by corpuscles. These general properties are as follows: Shape, that property whereby Substance takes up room. This property manifests in three directions, called dimensions of space, namely, length, breadth, and thickness. Weight, that property whereby Substance responds to gravity. Weight is simply the measure of the attraction. Impenetrability, that property whereby two bodies of Substance are prevented from occupying the same space at the same time. A nail driven into a piece of wood simply pushes aside the molecules and occupies the space between them. Substance is never actually invaded, or its actual territory occupied by other Substance. Indestructibility, that property whereby Substance is prevented from being destroyed or annihilated. Although the forms of Substance may be changed or transformed into other forms, still, Substance in itself is not destroyed, and cannot be under the existing laws of the Universe. Mobility, that property whereby Substance responds to imparted motion. We shall notice this property in our consideration of motion. In addition to the motion of the mass, and the movements of molecules and atoms in response to its attraction, there is another form of motion constantly going on, without reference to the attraction or impressed motion of the mass. The molecules of all bodies are always in a state of rapid motion, called vibration. In solids this vibration is short, being restrained by the close cohesive position of the molecules. But in liquids, the molecules being further separated, the vibration is far more rapid, and they move around and slide over each other with comparatively little resistance. In gases and vapors the molecules have a splendid field for motion, and consequently vibrate in wide fields and orbits, and dash around with the greatest velocity. The atoms, also, are believed to vibrate rapidly in accordance with their own laws of vibration. And the corpuscles are believed to far excel the last two mentioned particles in intensity, rapidity, and complexity of their vibrations, as we shall see a little later on in the book. All Substance is in constant motion and vibration. There is no rest in Substance. Inertia, that property whereby Substance may not move unless in response to imparted motion, nor terminate its motion when it is once imparted, except in response to some other manifestation of impressed force. Science holds that this impressed force or imparted motion must come from without, but the writer holds that force may also be expressed from within, as may be seen by reference to subsequent chapters of this book. Attraction, that property whereby particles or bodies of Substance 1. Draw other particles or bodies toward themselves, or 2. Move toward other particles or bodies, or 3. Are mutually drawn together. This property manifests in four forms, generally referred to as separate and distinct from each other, but which the writer believes to be but forms of the same attractive power, and which he believes to be a mental process, at the last analysis, a revolutionary claim which will be supported by argument in later chapters of the book. These three forms of attraction are known as 1. Gravitation, 2. Cohesion, 3. Adhesion, and 4. Chemical Affinity, or Chemism. We are invited to consider them briefly at this point, further investigation being reserved for our chapters on Motion and Dynamic Thought. Gravitation. This term is usually applied to the attraction between masses of substance, such as the sun, the earth, and masses of substance on or about the earth's surface. However, Newton, who discovered the facts of gravitation, states the law as "every particle of matter in the universe attracts every other particle," etc. Cohesion. This term is used to indicate the attraction between molecules by which they are combined into masses or bodies. Cohesion causes the molecules to unite and cling together, thus forming the mass. Adhesion. This term is used to indicate the attraction between masses which causes them to stick together, without a cohesion of their molecules. Adhesion operates through the adjacent surfaces of the two masses. It may be considered as a lesser form of cohesion. Chemical Affinity, sometimes called chemism or atomic attraction. This term is used to indicate the attraction between the atoms, by which they combine, unite, and cling together, forming the molecule. Science has before it the task of naming and classifying the attraction between the corpuscles by which they combine and form the atom. But whatever the name, it will be seen that it represents but another manifestation of attraction. Arising from molecular attraction or cohesion are several properties peculiar to masses having molecules, and resulting from the tendency of the latter to resist separation. We had better consider them briefly, in order to understand the power of molecular attraction and its incidents. Porosity. This property indicating the distances observed by the molecules in their relation to each other, which varies in different kinds of substance. All substance is more or less porous, that is, has more or less space existing between the molecules. The degree depends upon the closeness. Compressibility and expansibility, sometimes mentioned as properties, are but results of porosity. Elasticity. That property whereby bodies resume their original size and form after having been compressed, expanded, or bent. The result is caused by the inclination of the molecules to resume their original positions. What is sometimes called plasticity is merely the reverse of elasticity, and denotes a limited degree of the latter. Hardness. That condition resulting from molecular attraction resisting the forcible entrance and passage of other substance between the molecules. Tenacity. That condition resulting from molecular attraction resisting the forcible pulling asunder or tearing apart of the mass. This condition sometimes is called toughness. Malleability. That condition resulting from molecular attraction resisting the forcible separation of the mass by pounding, hammering, or pressure. The resistance is passive, and consists of the molecules allowing themselves to assume a spread out formation rather than to be forced apart. Ductility. That condition resulting from molecular attraction resisting the forcible separation of the mass by a drawing out process. The resistance is passive, and consists of the molecules allowing themselves to be drawn out into a formation of the shape of wire or thread, rather than to be pulled apart. In any of the above cases we may intelligently and with propriety substitute the words molecules by means of cohesion, resisting, etc., for the terms above used, molecular attraction, resisting, etc. All masses of substance, probably molecules as well, are capable of expansion and contraction, both phenomena in fact and in degree resulting from the relation of the molecules. Contraction is a crowding together of the molecules; expansion, a getting apart of them. Density, the amount of substance in relation to a given bulk. Volume, the size or bulk of a body of substance. Mass. Besides being used to designate a body of substance composed of two or more molecules, the term mass is used to designate the total quantity of substance in a body. An application of the above terms may be seen in the following illustration. A quart of water occupies a certain space, and has a certain volume, mass, and density. Convert the same mass of water into steam and it expands to a volume of 1,700 times that of water, but as no molecules have been added the mass remains the same. But as a quart of steam weighs 1,700 times less than the same volume of water, the density of steam is 1,700 times less than that of water. As the volume of a given mass increases, the density decreases in the same proportion, but the mass remains the same. Mass therefore has two factors, i.e., volume and density. The density of a mass is determined by the weight of a certain volume of it. The above consideration of the properties of Substance dealt only with the molecular properties, or physical properties, as they are sometimes called, that is, with properties depending upon the existence of the molecules. When we consider the molecules as being composed of atoms, and when we consider the processes whereby these molecules are built up of, or broken down through the separation of atoms, we come to the subject of atomic properties, or chemical properties, as they are often called. The atomic properties of Substance consist principally in the power and manifestation of motion, in the direction of combination, separation, and the complex motions resulting from the same. This motion is manifested by reason of atomic attraction, sometimes called chemical affinity, which we shall consider a little later on in this chapter. Atomic principles, as above mentioned, are best illustrated by a reference to chemical changes, and we shall now examine the same. And the better way to consider chemical changes is by comparing them with physical changes, or changes of the molecules. Some physical changes in Substance are brought about by heat, which tends to separate the molecules, or rather to allow them to spread out away from each other, so long as the high temperature is maintained, the degree of their nearness being influenced by temperature. Other physical changes are produced by outside forces, separating the molecules to such an extent, to such a distance, that their cohesive force is lost, and the solid matter is said to be broken, or even reduced to dust. Other physical changes are brought about by electricity, causing the molecules to separate and disintegrate. Chemical changes, as distinguished from physical changes, do not involve or deal with molecules, the action being solely upon the atoms of which the molecules are composed. Physical changes separate molecules from each other, while chemical changes destroy and break up the molecule, so that its identity is forever lost, its atoms therefore either existing free-form combinations, or else recombining with other atoms and forming new combinations. Chemical changes are occasioned by either physical or chemical agencies. The physical agencies generally employed are heat, electricity, light, pressure, percussion, etc. The principle of chemical changes is that the atoms are possessed of, and subject to, what is called atomic attraction, or chemical affinity, which may be defined as an attraction or love existing in varying degrees between atoms. This affinity causes atoms of one element to seek out and ally themselves to atoms of another element, the element of choice or preference being strikingly in evidence. Atoms of different elements form marriages and cling together in harmony until perchance by some physical or chemical agency the molecule is brought in sufficiently close connection with another molecule composed of different elemental atoms, when, alas, one of the atoms of our molecule finds that it has a greater affinity for some other elemental atom in the second molecule, and lo, it flies away, leaving its first partner and seeking the new charmer. Divorce and remarriage is a common thing in the world of atoms. In fact, chemistry is based upon these qualities. Physical and chemical changes gradually transform solid rock to earth or soil. Disintegration, by the action of changes in temperature, rains, and atmospheric influences, and other physical changes, have slowly worn down the rocks into dirt, gravel, clay, loam, etc., and decomposition by chemical change that set the atoms free from their combination has aided in the work. There is no rest in the world of Substance. Everything is changing, constantly changing. Old forms give way to new, and these, grown old while being born, are in turn replaced by still newer, and on endlessly. Nothing persists but change, and yet nothing is destroyed, although countless forms and shapes have succeeded each other. Substance is always there, undisturbed and unaffected by the varieties of forms it is compelled to undergo. Masses may change, and do change. Molecules may change, and do change. Disintegration and decomposition affect both, and bring to them the death of form. But their substance endures in the atom. Atoms may change and decompose, or undergo whatever change that is their fate, and still the corpuscles, or what lies beyond the corpuscles, will remain. The atom was once regarded as eternal, but now even it seems to be capable of dissolving into some finer division of substance, and perhaps still finer subdivisions await it. That familiar form of substance that we call earth, dirt, soil, etc., is but the result of disintegrated rock, which has crumbled and lost its former form through the action of air, water, and atmospheric influences. And the rocks themselves, from which the soil came, were at one time a sea of melted, flowing liquid substance, somewhat resembling volcanic lava. And this melted rock is thought to have been condensed from the same principles in the shape of vapor that existed in the early days of our planetary system. Vapor, gas, liquid, semi-liquid, solid rock, soil, the substance unchanged, the forms totally unlike. Helmholtz estimates the density of the nebulous vapors of Substance as being so rare that it would take several millions of cubic miles of it to weigh a single grain. Oh, Nature, what a wizard thou art! We have spoken of air and water in a former chapter, and their constituent atoms have been named. And from these three great reservoirs of Substance, the earth, the air, and the water, are obtained all the material that goes to form the bodies of the animal and vegetable kingdoms. The plant draws its nourishment from the soil, the air, and water, and in its wonderful chemical laboratory is able to transform the elements so drawn from these sources into a substance called plasm, which consists principally of carbon, oxygen, nitrogen, and hydrogen, being nearly identical in composition to the white of an egg, and which constitutes the basis of animal and plant bodily structures. All the material of the physical bodies of men, animals, and plants are but forms of plasm. The animals and man obtain their nourishment directly or indirectly from the plant body, and so at the last we are seen to draw from the soil, air, and water all our bodily nourishment, which we convert into bodily structure, bone, muscle, flesh, blood, veins, tissues, cells, etc. And the chemical atoms of our bodies are identical with those in the rock, the air, the water. And so you see the universality of Substance and its countless forms and appearances. Chemistry resolves Substance back into about 75 simple substances, of which atoms are the units, which simple substances are called elements. From these elements, by their atoms, all other substances are formed by combinations, the number of such possible combinations being infinite. An element, in order to be an element, must be a simple substance, that is, must be incapable of further analysis into some other elements. The 75 elements now recognized by science have never been resolved into other elements by chemical analysis, and therefore are accepted as simple. But it is true that other substances that were formerly considered as simple elements were afterward decomposed by electricity and found to consist of two or more simpler substances or elements. Thus new elements were discovered, and old ones discarded as not elemental. And this fate may be in store for a number of the elements now on the list, and many new ones may be discovered. For a long time science was endeavoring to trace all elements back to hydrogen, the latter being considered the ultimate element, and its atoms composing all the other atoms under varying conditions, etc. But this theory is now almost abandoned, and science rests on its list of 75 elements, the atoms of which are composed of electrons. Some have hazarded the theory that the elements were all forms of ether (see next chapter), their apparent differences resulting merely from the varying rate of vibration, etc. And in fact such theory was about finally adopted as a working hypothesis until the discovery of the corpuscle. Everything in Substance now seems to be moving back to the corpuscle, as we shall see a little further on. The following is a list of the principal elements known to science today: aluminum, antimony, arsenic, barium, bismuth, boron, bromine, cadmium, calcium, carbon, chlorine, chromium, cobalt, copper, fluorine, gold, hydrogen, iodine, iron, lead, magnesium, manganese, mercury, nickel, nitrogen, oxygen, phosphorus, platinum, potassium, radium, silicon, silver, sodium, strontium, sulfur, tin, zinc. Of the above, hydrogen is by far the lightest in weight. In fact, it is used as a unit of atomic weight, its weight being marked 1 on the scale, gold 197, lead 207, silver 108, oxygen 16, nitrogen 14, iron 56. The discovery of the corpuscle or electron rudely shattered the vortex ring theory of the origin of the atom, and now, instead of the atom being regarded as a vortex ring in that hypothetical, paradoxical absurdity, the ether, it is believed to be composed of a vast number of tiny particles called corpuscles, as we saw stated in our last chapter. These corpuscles seem to be the last thing in Substance, its last known state of refinement, and already it is being proclaimed as the last sought for Primal Matter or Ultimate Substance. Whether or not a still finer state of Substance will be discovered, science is unable to say, but thinks it unlikely. But we must not overlook the old Occult teaching, indicating a state of Substance so fine that it is imperceptible, and only recognizable as apparently Free Force, its covering or vehicle of Substance not being evident. This would seem to indicate a still further refinement of Substance, although perhaps the corpuscle or electron will answer to fill the bill in the case. As to the corpuscle being Primal Substance, it must be admitted that its advocates have presented a very strong case. One of their most important points is that although molecules differ very materially from each other according to their kinds, and while atoms likewise manifest very plainly their kind, the corpuscle seems to possess only one kind, no matter from what form or kind of substance it is thrown off. Just think what this means. It means that the finest particles of gold, silver, iron, hydrogen, oxygen, and all the rest of the elements are composed of identically the same material, and exhibit no differences in kind. The elements are no longer simple; all Substance is one, at the last analysis. The corpuscles seem to possess the same mass, to carry the same charge of electricity, to act precisely the same, irrespective of their source. No difference in size, mass, or character, as in the case of the atom. All are identical, save in the rate of their vibration at the time of observation, which is simply a matter of more or less motion. Space seems to be flooded with these tiny particles, these units of Substance. They stream from the sun, the stars, and every body highly heated. Likewise they stream from the bodies of highly electrified Substance. Groups of these corpuscles, absolutely identical in nature, size, mass, etc., constitute the atoms of the 75 elements, the kind of element seemingly being dependent upon the number and arrangement of the corpuscles and possibly their rate of vibration. Every atom is like a great beehive with a swarm of corpuscles vibrating, moving around each other, and upon their own centers. And if by the action of intense heat, transmitted or caused by interrupted motion, or if by a strong electric charge, some of these corpuscles are detached from the atoms, or possibly an atom broken up, they fly off through space at a marvelous speed of many thousand miles an hour. So we see that these wonderful corpuscles look very much like Primal Matter or Ultimate Substance, the stuff out of which Substance is made. And taking you back to the chapter on the Universality of Life and Mind, the writer would remind you that in their motions and evident attraction, etc., these corpuscles evidence the same "life and mind" that we observed in the molecules and atoms. It must be so, for what is in the manufactured article must be in the material of which the article is made. And so, even here, Life and Mind have not escaped us, nor will it in the Ether. And speaking of the corpuscles as manufactured articles, we are reminded of Herschel's thought about the atoms, when they were regarded as primal matter and likely to be uniform and, at the end, of one primal substance. Although Herschel's conception does not now apply to the atoms, it may be transferred to the corpuscles. Herschel thought that the fact that the particles of Substance were likely to be found to be uniform in size and identical in nature and characteristics indicated that they might be akin to manufactured articles, turned out from the same great machinery of creation. This idea would indicate that the Creator applied the rules of careful manufacture to the manufacture of the particles, the uniformity operating in the direction of 1. Economy of material, 2. Utility through interchangeability, replacing broken or discarded parts, etc., and also 3. Conformity to a standard of size, quality, etc. The thought is interesting, and is mentioned here for that reason. It is not affected by the supposition that there may be a still finer and rarer form of Substance from which the particles are manufactured. In fact, the idea of Herschel, if closely analyzed, would seem to indicate some such raw material from which the articles were manufactured. End of Chapter 6. Chapter 7. Thought, or The Law of Vibrant Energy, by William Walker Atkinson. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Sandra Knight. www.sandraknight.net. The Paradox of Science. In the days of the ancients, when the philosophers found themselves unable to account for any particular class of phenomena, they bundled it together and referred it to a supposititious something that they called the Ether. Finding this an easy way to get rid of vexatious questions, they fell into the custom, and the habit grew upon them. Soon there were a dozen or more different kind of ethers in vogue, each explaining something else, the something else, by the way, being things that science now feels that it understands pretty well. These ethers grew to be like the various vapors of the ancients, a dignified term for "we don't know," a respectable road for retreat under the semblance of an advance. These ethers became a scientific scandal, and caused a lax mode of thinking among students of those times. And so they were finally abolished and relegated to the scrap pile of science, where they lay for many centuries until a comparatively recent period, when at least one of them was hauled forth, dusted, freshened up a little, and placed upon its old pedestal. This revamped ether referred to was the ether of Aristotle. Aristotle, as we know, was a famous Greek philosopher who lived about 350 B.C., about 2,250 years ago. He was a good man and a celebrated philosopher, but was somewhat deficient in scientific knowledge. Although he knew many things and uttered many wise thoughts, he was under the impression that the breath of man entered the heart instead of the lungs, that the back part of the skull was empty, and so on. He was without the advantages of a modern training, which was not his fault, however. Well, Aristotle conceived the idea of a universal ether, which he thought pervaded all space, and with which he accounted for the passage of light from the sun and stars, the movements of the planets, and various other physical phenomena. It is not known whether Aristotle really believed in this ether, or whether he merely used it as a speculative hypothesis, following the ether habit of his contemporaries. At any rate, his theory served its purpose, lived, flourished, declined, and died, at least seemed to be dead. But its corpse was resurrected in modern times and used to account for diverse things. This does not mean that modern thinkers really believe in the universal ether. They merely assume it as a working hypothesis, until something better is offered. Its principal modern use is to account for the transmission of light from the sun and stars to the earth. It was held that a thing could not act where it was not, and so it became necessary to account for the transmission either by the theory that small particles of Substance were thrown off from the Sun and traveled to the Earth, or else that there was some medium of communication by means of vibrations, etc. Newton held to the first theory, but his hypothesis went down before the Ether advocates, who advanced the wave theory, although it seems that, like Banquo's ghost, Newton's theory will not stay down, and is now taking on a new lease of life, owing to the discovery of the corpuscle and radiant matter. The wave theory philosophers asserted that the light and heat of the Sun were thrown off in the shape of force or energy, and transformed into waves in and of a hypothetical ether, Aristotle's own, which waves were carried to the Earth, where meeting Substance they were again transformed into heat and light. It was known that light and heat traveled at the rate of 184,000 miles per second, and therefore the waves of the ether were considered to have that speed. The wave theory seemed to fit the facts of the case better than the Newtonian theory of corpuscles, although the latter has always been considered as better explaining certain phenomena than the new theory, and so the ether wave became generally accepted, and remains so today, although recent discoveries are causing a disturbance in the scientific camp regarding the question. Later it was discovered that the electricity traveled at the same rate as light and heat, and the wave of the ether theory was thus thought to have additional verification, and electricity came under the law and remained there until the electron discovery, which is causing much disturbance among those interested in the study of electricity. Briefly stated, the theory of the universal ether is this: that pervading all space in the universe, not only between planets, stars, and suns, but also, filling in the cracks, between molecules and atoms as well, there is a subtle substance in and through which the waves of light, heat, electricity, and magnetism travel at the rate of 184,000 miles per second. This substance is said to be matter that is not matter. In fact, science does not venture to say just what it is, although it freely states just what some of its properties must be, and alas, these properties are most contradictory and opposite to each other, as we shall see as we proceed. The universal ether is purely hypothetical. It has been called a necessity of science, something assumed for the purpose of explaining or accounting for certain phenomena. It is undemonstrated and unproved. In fact, may truthfully be said to be undemonstratable and unprovable. Some have gone so far as to say that its claimed properties and qualities render it unthinkable as well. And yet, science finds itself compelled to assume that the ether, or something like it, exists, or else cease speculating about it. It belongs to the realm of pure theory, and yet many writers treat it as if it were a positively demonstrated and proven fact. Let us examine into the nature of Science's problem and her attempted solution, and the trouble arising therefrom. Light travels at the rate of 184,000 miles a second. Remember that light and heat are that which we call by those names only when considered in connection with Substance. According to the theory, light in the Sun's atmosphere is transformed into a light wave of the ether on its travels to the Earth, and only when the wave comes in contact with the Substance on the Earth's body or atmosphere does it become again transformed into light as we know it. In its travels through space it meets with no Substance, and has nothing to turn into light, consequently space, between worlds, is in a state of absolute darkness. The same is true of heat, and inner world space is absolutely cold, although passing through it are countless heat waves of great intensity which, later on, will be transformed into heat when they reach the Substance, the Earth. The same is true of electricity and magnetism. Although the ether, as we have seen, is a purely theoretical substance, yet science has found it reasonable to conclude that it must be possessed of certain attributes in order to account for certain known facts. Thus, it is said to be frictionless, else the worlds, suns, and planets could not pass freely through it, nor could the light and heat waves travel at such a tremendous rate. It also is thought to have something like inertia, because motion once started in it persists until stopped. Because it is at a state of rest until motion is imparted to it, and because it takes a fraction of time to impart motion to it, it is thought to be different from Substance in any of its known forms, for many reasons, among such being the fact that no known form of Substance could carry vibrations through space at the rate of 184,000 miles a second. And light and heat waves travel at that rate and have forms and shapes and lengths of their own. Light, for instance, vibrates on two planes, and a light wave is something like a Greek cross, thus having a horizontal and a vertical line or plane of vibration. And the ether cannot be a fluid of any degree, because a fluid cannot transmit cross vibrations at all. And it cannot be a solid, because a solid could not stand vibrations at such a terrific speed and still remain a solid. And yet, to transmit the two-plane light waves, the ether must have a certain degree of rigidity, else the waves could not travel. Lord Kelvin estimated this degree of rigidity as about 19 billionth of the rigidity of the hardest steel. So you see, science is compelled to assume that the ether is a continuous, frictionless medium, possessing both inertia and rigidity. Some scientists have thought it to be a kind of elastic jelly. Of the ether, Professor Oliver Lodge has said, "We have to try and realize the idea of a perfectly continuous, subtle, incompressible substance pervading all space, and penetrating between the molecules of ordinary matter, which are embedded in it, and connected to one another by its means. And we must regard it as the one universal medium by which all actions between bodies are carried on. This, then, is its function, to act as the transmitter of motion and energy." To give you an idea of the wonderful thing that science is compelled to think of the ether as being, by reason of the qualities it is compelled to ascribe to it, although it confesses itself unable to imagine the nature of the thing which it has created in bits by the adding and bestowing of qualities which were made necessary by the logical requirements of the case, let us take a hurried view of the thing as the several departments of science say it must be thought of. To meet the requirements of the case, science says that the universal ether must be substance infinitely more rare and evanescent than the finest gas or vapor known to science, even in its rarest condition. It must convey heat in the manner of an infinitely solid body, and yet it must not be a solid. It must be transparent and invisible. It must be frictionless and yet incompressible. It cannot be a fluid. It cannot have attraction for Substance, such as all Substance has, nor can it have weight, that is, it is not subject to gravitation. It is beyond the reach of any known scientific instrument, even of the greatest power, and it refuses to register itself in any way, either to senses or instruments. It cannot be known of itself, but may only be recognized as existent by the things for which it acts as a medium or transmitting agent. It must convey energy and motion, yet it must not take up any part of either from the matter in its midst. It must not absorb any of the heat, light, or electricity. It must fill up the spaces between the worlds, as well as the most minute space between the molecules, atoms, and corpuscles, or any other minute particle of Substance, either known by name to science now, or which may be discovered or imagined later as a necessity of some conception regarding the nature of Substance. In short, the universal ether, in order to do the things attributed to it, must be more solid than solids, more vapor-like and gas-like than vapor or gas, more fluid than fluids, infinitely less rigid than steel, and yet infinitely stronger than the strongest steel. It must be a substance having the qualities of a vacuum. It must be continuous and not composed of particles, atoms, or molecules. It must be an everything in some respects, and yet a nothing in others. It must not be substance, and yet it must carry substance within its ocean of dimensions, and besides interpenetrate the most minute space between the particles of substance. It must not be energy, or force, and yet Science has been considering energy and force as but interruptions of rest or agitations within and of itself. So you see that this mysterious, wonderful universal ether, in order to be at all, must be a something possessing certain qualities or properties of substance, many of the properties of qualities being exactly contradictory and opposed to each other, and yet it cannot be substance as we know it. It is a paradoxical thing. It could only belong to another and an entirely different order of existence from that of substance as we know it. It must possess characteristics and properties of an order as yet unknown to us by name, for which the material world contains no analogy, for which substance has no analogues. It must be a far more complex thing than is even the most complex thing we call matter, or that which we call force or energy. And yet it has been claimed that it would explain both, yes, contain within itself the possibility of both. And yet, in face of what has just been said, the writer must confess, humbly and with a full realization of the enormity of the offense, that he supposes advancing a theory a little further on in this book that will attempt to identify this something, this universal ether, with a something else that we know, although not through the senses or by means of instruments. Bear with him kindly, he begs of you, while he proceeds gradually along the path that leads to the theory. Scientists have compared substance moving through the ether as a coarse sieve moving through water, the latter making room for the passage of the sieve and then closing up behind it. If this be amended by the idea that the moving sieve, while allowing the water to pass through it freely, still carries along with it a thin film of water which clings to the wires of the sieve by adhesion, if there be admitted this clinging film, as well as the body of the water through which the sieve moves, then the illustration answers quite well as a crude illustration of substance and the ether. This fact is important in view of the theory that will be advanced further on in this book. Professor Lodge, in his interesting work, Modern Views of Electricity, mentions a number of experiments tending to prove the above mentioned fact, which is not so generally known as other facts relating to the ether, until the discovery of radiant matter, bringing with it the new theories of the corpuscle or electron, etc., brushed aside into the dust heap many generally accepted scientific theories regarding the nature of substance. The favorite and most popular theory was what was known as the vortex ring, the theory of the atom. This theory held that the atoms of substance were but vortex rings of the ether, having had motion communicated to them in some way, and which afterwards acquired other motions, and which finally become apparent to our senses as substance. In other words, the atom was supposed to be a vortex ring of ether, acted upon by force, in some unknown way, the character, nature and properties of the atom being determined by the shape and size of the vortex ring, the rate of motion, etc., etc. The new discoveries of science, however, have set aside, at least temporarily, this vortex ring theory, and at present Science seems to find its latest thing in substance, in the theory that substance, at the last, seems to be the corpuscle or electron. In other words, after many years of fancied security in a settled theory regarding the nature of substance, Science once more finds itself compelled to take up the search for the origin of things. But the theory of the ether remains, and is likely to, although the names applied to it will change. By some it is still believed that in the ether, a little further removed, rests the origin of substance, and that the corpuscle may be the vortex ring product, instead of the atom. It will be noticed that Science has made no serious attempt to connect the phenomenon of gravitation or attraction with the ether. Gravitation stands alone, an outsider among the forces, responding to none of their laws, needing no time in which to travel, needing no medium like the ether in which to transmit waves, fearing no obstacle or interfering body, but passing right through the same, different. And we shall see why this difference when we reach the point where our theory brings us to the point where we must substitute something else for that great paradoxical general solvent of modern science, the ether of Aristotle. We shall reach the point after a brief consideration of motion, force, and energy. End of Chapter 7. Chapter of Dynamic Thought, or The Law of Vibrant Energy, by William Walker Atkinson. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Forces of Nature. The substance filling the universe is in constant and unceasing motion. Motion is evidenced in every physical and chemical process and change, and manifested in the constant interchange of position of the particles of substance. There is absolutely no rest in nature. Everything is constantly changing, moving, and vibrating. Building up processes are ever at work forming larger masses of bodies of the particles, and tearing down processes, disintegration and decomposition of molecules and atoms and corpuscles are constantly at work also. Nature maintains a constant balance among her forces. If the building up energies and forces were allowed full sway, then all the particles in the universe ultimately would gravitate to a common center, thus forming a compact and solid mass, which would thus dwell for eternity unless the creative power should move upon it and again scatter its particles in all directions. And if the tearing down and dispersive forces and energies were allowed full sway, the particles would fly apart and would remain asunder for eternity, unless called together by some new creative fiat. But Nature pits one force against another, maintaining an equilibrium. The result is constant play and interplay of forces, causing distribution and redistribution of particles, following the gathering together and building up processes. There is no lost motion or waste force. One form of force and motion is converted into another, and so on and on. Nothing is lost, all force is conserved, as we shall see as we proceed. In the public mind, or rather, in the mind of that part of the public which think of the matter at all, there seems to be an idea that Force is something of the nature of an entity, separate from Substance or Mind, something that pounces down upon Substance and drives it along by presence from without. The ancient philosophers regarded Substance as acted upon from without by an entity called Force, Substance being regarded as absolutely inert and dead. This idea, which is still held by the average person, owing, doubtless, to the survival of old forms of expression, was generally held by philosophers until the time of Descartes and Newton. This old idea was due to the teachings of Aristotle, he of the ether theory, and science and philosophy were timid about shaking off the Aristotelian dogmas. Others held that light, heat, and electricity were fluids, conveyed from body to body. In fact, the general public still entertains this idea regarding electricity, owing to the use of the term "the electric fluid." The present teaching of science is that Force is the result of the motion of the particles of Substance, and of course originates from within rather than from without. It is true that motion may be communicated to a body by means of another body in motion, imparting the same to it, but that does not alter the case, for the original motion came from the movement and vibration of the particles of Substance, although it may have passed through many stages of transformation, change, and transmission in its progress. The only exception to the rule is gravitation, which is a form of force, the nature of which is unknown to science, although its laws of operation, etc., are understood. We shall learn some new facts about gravitation in the forthcoming chapters of this book. It will be well for us to remember this fact, in our consideration of Force and Motion, that Force and Motion originate from the inherent property of motion passed by the particles of Substance, and come from within, not from without. This is the best teaching of modern science, and also forms an important part of the theory of dynamic thought which is advanced in this book. Buckner, the author of Force and Matter, vigorously insists upon this conception, saying, among many other similar expressions, Force may be defined as a condition of activity or a motion of matter, or of the minutest particles of matter, or a capacity thereof. The term force is generally defined in works on physics as that which causes, changes, or terminates motion. The word force is generally used in the sense of in action, while energy is usually used in the sense of potential force, capacity for performing work. The idea being that it is stored up force or force awaiting use. The term power is used in two senses, the first meaning a measure of mechanical energy, such as a 40 horsepower engine, etc. The second sense being capacity or ability to act, or exercise force. This use being almost identical to the idea of energy as above described, although possibly a little stronger expression. The materialistic school holds that force is a property of matter, the latter being regarded as the real thing of the universe. Others hold that force is the real thing, and that what is called matter or substance is but a center of force, etc. Others hold that the two are but aspects of the same thing, calling the thing by the name matter-force, or force-matter. Haeckel calls the combined thing by the name of substance, claiming that what are called matter and force are but attributes of it, the third attribute being sensation, which he holds is akin to mind. Haeckel's substance is held to be eternal and self-existent, its own cause, in fact. In this book the term substance is not used in this sense, but merely as synonymous with what science usually calls matter. The views advanced in this book differ materially from any of those above mentioned, it being held by the writer that all force is vital mental force, and consequently force, as a separate thing, is considered an unreasonable proposition, what is called force being considered merely an action of mind upon substance, causing motion. The writer does not intend to advance this idea at this point beyond the mere mentioning of the fact, the theory being brought out and developed as we proceed, and he will proceed to a consideration of the phenomena of force along the lines of modern science, believing that in this way the subject may be better understood. The term motion, as used in physics, is defined as the act, process, or state of changing place or position, movement, Webster. So you see, motion is the movement of substance, changing place or position. Force is that which causes, changes, or terminates motion, and energy is the capacity for manifesting force, and power the ability to act. In works on physics you will notice the expression potential energy, meaning energy awaiting action, also kinetic energy, meaning energy in action, that is, in motion. We shall not need these terms in this book, but it is well to understand them. Another term frequently met with is conservation of energy, which is used to indicate the law of physics, the operation of which renders energy indestructible. That is, science holds that energy cannot be destroyed, that it is not lost or created, but is merely transformed into other forms of energy, potential or kinetic. Therefore, after energy is used, it either passes into a state of potential energy or rest, awaiting a future call to activity, or else is immediately transformed into another form of kinetic energy, or energy in action. The theory holds that the quantity or amount of energy in the universe is fixed in its totality, none may be created or destroyed. There can be no addition to or subtraction from the totality of energy, that all energy used has been previously stored up, or else has been immediately transmitted or transformed. It is also held that when energy manifests as the result of work performed, it is always found that it is at the expense of some previously manifested form of energy; that the agency by which the work is performed always parts with its stock of energy, and that the thing worked upon always acquires or gains the amount of energy lost by the aforesaid agent, or worker, and yet there is no actual loss or gain, but merely transformation. The above theory is mentioned as of interest in the general subject, although it does not play a prominent part in the subject of this book. For the writer holds that all energy resides in Mind, and emerges therefrom, and in the end returns thereto. This being believed, it is seen that energy is not to be thought of as a separate thing having a totality, but merely as a quality of Mind. The question of its totality or fixed quantity not being inquired into, although both probably run along the lines of the nature of Mind, and depend upon the limitations or lack of limitations of the latter. However, the question does not assume a vital importance in our consideration of the subject. So far as the question of transmission, or transformation of energy, is concerned, however, the principles of the Law of Conservation of Energy may be accepted as correct, although it more properly belongs to the principle of what has been called the correlation of force, the idea of which is that one form of energy may be, and is always, transformed into another form, and so on, and on, unto infinity. This idea is followed in this book, except that the idea of "from Mind originally to Mind finally" is incorporated within it. This law of the correlation of force may be illustrated by the following quotation from Tyndall, the great scientist of the last century, who says: "A river, in descending from an elevation of 7,720 feet, generates an amount of heat competent to augment its own temperature 10 degrees Fahrenheit, and this amount of heat was abstracted from the sun in order to lift the matter of the river to the elevation from which it falls. As long as the river continues on the heights, whether in the solid form or as a glacier, or in the liquid form as a lake, the heat expended by the sun in lifting it has disappeared from the universe. It has been consumed in the act of lifting. But, at the moment that the river starts upon its downward course and encounters the resistance of its bed, the heat expanded in its elevation begins to be restored. The mental eye, indeed, can follow the emission from its source through the ether, as vibratory motion, to the ocean, where it ceases to be vibration and takes the potential form among the molecules of aqueous vapor, to the mountain top, where the heat absorbed in vaporization is given out in condensation, while that expended by the sun in lifting the water to its present elevation is still unrestored. This we find paid back to the last unit by the friction along the river's bed, at the bottom of the cascade, where the plunge of the torrent is suddenly arrested, in the warmth of the machinery turned by the river, in the spark from the millstone, beneath the crusher of the miner, in the Alpine sawmill, in the milk churn of the chalet, in the supports of the cradle in which the mountaineer, by water power, rocks his baby to sleep. All the forms of mechanical motion here indicated are simply the parceling out of an amount of calorific motion derived originally from the sun, and at each point at which the mechanical motion is destroyed or diminished, it is the sun's heat which is restored." The following quotation also is interesting as illustrating another phase of this law. "The work performed by men and other animals is due to the transformed energy of food. This food is of vegetable origin and owes its energy to the solar rays. The energy of men and animals is, therefore, the transformed energy of the sun. Excepting the energy of the tides, the sun's rays are the source of all the forms of energy practically available. It has been estimated that the heat received by the earth from the sun each year would melt a layer of ice over the entire globe 100 feet in thickness. This represents energy equal to 1 horsepower for each 50 square feet of surface." Anthony and Brackett. From the above quotations, it will be seen that the principal and most familiar sources or great storage batteries, of energy apparent to dwellers upon this planet are 1. The Earth manifesting the power of gravitation, and 2. The Sun manifesting solar heat. In Tyndall's illustration we see the force of the Sun's energy, heat, raising the water from the ocean, by evaporation, although aided by the Earth's gravitation, pulling down the heavier air, allowing the vapor to rise. Then we see the force of gravitation causes the condensed vapor to fall as rain or snow on the mountain top, then causing the rain to run into little streams, and so on until the river is reached, then causing the river to start on its downward journey of over 7,000 feet, then causing it to plunge over the cascade, to turn the wheels that operated the machinery, and turned the millstone, and the crusher of the miner, and the sawmill, and the milk churn, and the cradle. And as Tyndall might have added, had he lived a little later, in the running of the dynamo, which running produced electricity, that in turn caused lights to burn, other machinery to run, and manufacture things, stoves to cook, flat irons to iron, automobiles and engines to run, and many other things along the lines of transmitting energy, force, and motion. And in this consideration, let us not forget the important part that gravitation, that most wonderful of all forces, plays in the grand scheme of Nature. Not only does this force cause the planets to circle around the Sun, and perhaps that Sun around another Sun, and so on until the matter becomes unthinkable. Not only this, but it performs 1,000,000 parts in the affair of earthly matter, as we shall see in a later chapter. The force of gravitation is one of the greatest mysteries confronting science today, although many believe it a simple question. Gravitation and the universal ether contain the great secrets of nature that man is striving to unveil. And yet so common is gravitation that the race, including almost all the scientists, take it as a matter of course. We shall devote much attention to the question of gravitation in the forthcoming chapters of this book, for it plays a very important part in the general theory of dynamic thought, upon which this book is based. We shall have a special chapter devoted to it, a little later on, and the matter will also come up for explanation further on in the book. But in the meantime, let us consider the other forms of energy, viz., heat, light, magnetism, and electricity, which with gravitation and attraction of other kinds, form the forces of nature. End of Chapter 8. Chapter of Dynamic Thought, or The Law of Vibrant Energy, by William Walker Atkinson. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Radiant Energy. The kinds of energy are very few, although the methods of using, applying, and manifesting same are innumerable. Let us begin with one of the best known forms of energy, namely heat. Heat was formerly regarded as a very fine fluid or substance called caloric, which was supposed to enter into substance and then manifest the phenomenon of heat. This idea has long been relegated to the scrap pile of science. The present theory, which is supported by a mass of evidence obtained through investigation and experimentation, is that heat is a form of energy arising from the vibratory motions of the particles of substance, a mode of motion. The degrees of heat are termed temperature. Temperature depends upon the rate of the heat vibrations of the particles of substance, either arising from the original motion of the particles, or else from vibrations or motion aroused in them by transmission from particles of other bodies of substance, these vibrations being contagious. Temperature then means the measure of the vibrations of the particles. All bodies of substance have some degree of temperature, some degree of heat vibration of its particles. Science has a pleasant scientific friction of an absolute zero at the degree of 491 below zero, Fahrenheit. But this is merely an imaginary something with which the grown-up children of science amuse themselves. When two bodies are brought near each other, the nearness being comparative, and in some cases meaning a distance of millions of miles. Heat is transmitted from the warmer to the cooler body, until the temperatures are equalized. That is until the two bodies vibrate in unison. In physics we are taught that the transmission of heat may be accomplished in three ways, although the writer is of the opinion that the three ways are but three forms of one way. The first form is called conduction, whereby the vibration or heat is conveyed along a body of substance from its warmer to its cooler parts, for instance, an iron poker with one end in the fire. The second form is called convection, whereby the visible motion of heated substance moving along the air, for instance, hot air, hot water, steam, etc., either by means of pipes or by allowing them to pass freely through the air. The third form is called radiation, whereby the vibrations are believed to be transformed into waves of the ether, which will be spoken of later, in addition to what has been said on the subject in our chapter entitled "The Paradox of Science." The writer thinks that a little consideration will show us that the same rule operates in all of the above cases, and that conduction and convection are but forms of radiation. For instance, in conduction there must be a few particles first set into vibration, the same gradually passing on to the others farther and farther away. Passing how? By contact, replies physics. But the particles are never in absolute contact. There always is plenty of space between them, and so there must be some kind of waves passing through the space between them, which space is not filled with air or other form of substance, but only with the ether or something that takes its place. So that, after all, conduction is but a form of radiation, and the same rule will apply in the case of convection. Heat arises from several causes, all of which, however, manifest through the vibration of the particles of the body evidencing the heat. These causes may be stated as 1. Original motion of the particles of a body of substance, arising from some workings of the law of attraction, and including motion arising from chemical action, combustion, etc. 2. From transmission or contagion from some other body of substance, the particles of which are vibrating at the rate of heat. 3. From interrupted motion, including friction, both of the moving body with the air or other substance, and the friction of a current or electricity passing through the body. In each of the above cases, the actual and immediate cause of the heat is the vibration of the particles of the substance manifesting the heat, although the transmitted vibratory waves, or the interrupted motion, friction, current, etc., may have been the instigator or provoker of such vibration. The interrupted motion, friction, or wave does not produce the heat, but merely arouses or provokes the increased vibration of the particles that really manifest the heat. At the least, remember, the heat is in the particles of the body that feels or experiences it. The vibrations of heat seem to have the properties of causing the molecules to draw further apart, and to manifest less attraction or more repulsion, whichever way one cares to express it. This moving away of the molecules tends to cause the body to increase in volume or size, and occasions what is known as expansion in substance. In this way heat transforms solids into liquids, liquids into gases or vapors, the change being wholly a matter of the relative distances of the molecules. Magnetism is another form of energy, and is generally believed to be a part of the phenomena of electricity, if indeed not a form of electricity itself. Science knows very little about the nature of magnetism, but in a general way holds to the theory that it results from the vibration or motion of the particles of substance, as do all other forms of energy. The magnetic qualities of a body may be increased or decreased by motion affecting the relation of the molecules, which fact has been regarded as having some bearing on the theory. Electricity is a form of energy that science regards as also arising from the vibration or motion of the particles of substance. It is transmitted like heat, by conduction and radiation, the waves tending to provoke similar vibrations in the particles of substances receiving them. By many careful investigators, Electricity is believed to be very closely related to the phenomenon called light, both having much in common. Science seems to be discovering new points of resemblance between them, and it is possible that in the near future they will be seen to be but varying forms of the same thing. The purposes of this book do not call for an extended consideration of the properties of electricity, the same being served by a consideration of its nature being akin to that of the other forms of energy, namely, vibration or motion in or among the particles of matter. Light is a form of energy, the study of which is of the greatest interest to science, for the reason that the field seems to be widening out continuously, and reaching out into the territory formerly thought to be the special region of electricity. And in another direction, it seems to be reaching out into the territory of heat, the latter being considered by many to be but a form of light, in its lower vibrations. In fact, the writer of this book so considers the subject, and for the purposes of this book, in latter chapters he will combine electricity, heat, and light, including also the phenomena known as the X-rays, Becquerel rays, radium waves, etc., as forms of light, the combined forms of energy to be called radiant energy. In this combination he believes that he is in line with the latest and best thought of modern science. However, he does not insist upon his readers following this idea, and so, if they prefer, they may think of each of these forms as separate and distinct, and yet not run contrary to the line of thought of the book. Light is not the simple thing that it is considered to be by the general public. It is composed of many parts, qualities, and manifestations. Its rays, when separated by the spectrum, are seen to consist of waves or vibrations of differing degrees of rate and intensity. The lower range contains the heat rays, and it is interesting to know that there are rays of heat too far down in the scale to be evidenced by human senses that may be distinguished by delicate instruments. But there are rays still further down in the scale that are known to exist, theoretically, that cannot be registered even by the finest instruments. To gain an idea of the delicacy of these instruments, let us remember that Professor Langley has an instrument called the bolometer that is so delicate that it registers a change of temperature of 1/1,000,000th of a degree, and will register the heat of a candle 1 1/2 miles distance from it. Light vibrations arise from combustion, friction, electricity, etc., causing the particles to assume increased motion. Let us consider the report of the spectrum. Beginning with waves or vibrations far below the sensibility of man, the scale shows an advance until the first warm vibration of iron was reached. This first indication of warmth comes when the vibrations reach the rate of 35 trillion per second. Then gradually they increase until a dull red glow is noticed, the lowest visible light ray, when the vibrations are 450 trillion per second. Then come the orange rays, then the golden yellow, then the pure yellow, then the greenish yellow, then the pure green, then the greenish blue, then the ocean blue, then the cyanic blue, then the indigo, then the violet, the latter evidencing when the vibrations reach the rate of 750 trillion per second. Then come the ultraviolet rays, invisible to human sight, but evidenced by chemical media. In this ultraviolet region lies the X-rays, etc., and also the actinic rays that produce photographs, sunburn one's face and blister the nose, that cause violent explosions in chemicals that transform forms of substance, that are employed to cure skin diseases, etc. These actinate or chemical rays have an important role to play in plant life, for they act upon the green leaves of the plant, causing a chemical change by which carbonic acid and water are transformed into sugar and starches. Some of the rays of the ultraviolet region of light penetrate substances formerly considered solid and impenetrable, and some of them, emitted from radium, etc., would destroy organic life if applied in sufficient quantities. Some of them are practically waves of electricity, so that light and electricity are seen to be closely related. To give one an idea of the differences produced by different rates of vibration, let us imagine a mass of iron shaped like a great top, capable of being impelled to spin at a constantly increasing rate of speed by some mighty will. At first it is seen as a slowly spinning top manifesting nothing but slow motion to our senses. Now imagine our top spinning at a rate doubling each second. The first second the top spins at the rate of 2 revolutions per second. We notice no change except that we can see the movement. The next second the revolutions are doubled to 4 per second. Then, doubling each second, we have, respectively, revolutions of 8 per second, then 16, and then in the 5th second, 32 per second. Then we begin to notice a change. When the revolutions reach 32 per second, the friction of the moving top on the air causes it to give forth a very low, deep bass note of sound. This note is like a low, deep hum, and is the lowest possible of perception by the human hearing, although it is possible that some of the lower forms of life may be conscious of still lower vibrations. The 6th second the revolutions reach 64, and the low note has grown much higher in the scale. The 7th second records a rate of 128, and the note has correspondingly increased. Then, as the seconds pass, we have successively 256, 512, 1024, 2048, 4096, 8192, 16,384, 32,768, the latter in the 15th second, and representing the highest note recognizable by the human ear, although it is believed that some of the lower animals may recognize sounds too acute for our sense of hearing. During this increase in revolutions from the 5th second to the 15th, the sound note has risen rapidly in the scale from the low sullen hum on through the notes of the musical scale and beyond the range of instruments until the shrillness becomes so intense as to be almost unbearable, and finally terminating in a shrill, piercing shriek like the squeak of the bat, only long drawn out. Then, from the termination of the sound, by reason of the rate of vibration having become too high, silence reigns for 30 seconds. Absolute silence, in spite of the rapidly increasing rate of vibrations, in fact, because of it. When the 45th second is reached, and the revolutions have reached the rate of 35,184,372,088,832 per second, our top begins to emit heat rays increasing each second. Then a little later a dull, dim glow may be noticed. Then, as the seconds fly, the dull glow manifests a deep dark red color, such as one notices in the iron of the blacksmith's shop soon after it begins to glow. Then, on and on, as the seconds fly, the deep red grows lighter and brighter, gradually changing into orange, then into yellow, then into green, then into blue, then into indigo, then into violet, and then into the color of white heat. Then this white heat changes into a still more dazzling white, and then a white impossible to describe appears, so bright, clear and brilliant that the eye cannot bear the sight. Then, suddenly, the intense brightness is succeeded by absolute darkness, and the moving top cannot be seen by the eye, and yet it moves on. The highest recorded chemical rays of light are estimated to equal a rate of vibration of 1,875,000,000,000,000,000 per second. The vibration of the lowest shade of red light is estimated at 450 trillion, and the highest of violet at 750 trillion per second. So we may imagine what the highest line on the spectrum is like. Still vibrating, our top, which has become now a mass of vaporized iron, rapidly tending toward still more ethereal forms, it has passed out from the region of light waves into another unknown region of vibrations, in which region, however, exist the vibrations known to us as the X-rays, etc. It is throwing off great quantities of electrons. If we were to use a fluorescent screen, we would be able to observe the phenomena of the Röntgen rays, and similar manifestations of radiant energy. On and on vibrates the top of what we once called iron, cold iron, warm iron, hot iron, melted iron, gaseous iron, etherealized iron, if you like. What it is like now, the imagination of man cannot conceive, Still the revolutions continue, doubling each second. What is being produced? The imagination cannot conceive of what this state of substance, now being reached, is like. By a scientific form of poetry we might think of it as melting into energy, pure energy, if there were such a thing. Long since it has been resolved into its original particles, its corpuscles, and perhaps into the stuff from which particles are made. But we must let the curtain drop. The wildest fancy cannot follow the dance of substance any further. The theory of the transmission of vibrations of radiant energy by means of waves in the ether, or something that takes the place of the ether, has been mentioned in other parts of the book. Referring again to it, the writer would say that he thinks it's probable that the waves, coming in contact with the countless corpuscles in the earth's atmosphere, communicate a high rate of motion to them, the result being that they take on the vibrations immediately and pass along with the wave current. The result being that much that we consider as waves of light, heat, and electricity are but streams of these corpuscles in which vibrations have been awakened by the waves. This idea will help to explain some of the phenomena of light which seemed more understandable under the old light corpuscle theory of Newton than under the wave theory of recent years. The idea is advanced merely for the purpose of setting down the thought, for it plays no important part in the theory of the book. Another matter that should not be overlooked in connection with light and heat and electricity is that particles absorb or catch the vibrations in different degrees, their receptivity depending upon their particular vibratory mode or custom of their kind. If unable to absorb the vibrations, they reflect them. Substance of any particular kind absorb heat in the degree of its atomic weight. In the next chapter we shall learn something of the law of attraction, that wonderful law that makes possible any motion or radiant energy. End of Chapter 9. Chapter Dynamic Thought, or the Law of Vibrant Energy, by William Walker Atkinson. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Sandra Knight. www.sandraknight.net. The Law of Attraction. In the previous chapters we have seen that all forms of radiant energy, viz., light, heat, electricity, and magnetism, arose from the motion of the particles of substance. It now becomes important to learn just what caused this motion of the particles. Science is somewhat hazy and foggy on this subject, but in a general way decides that it is caused by the mutual relations and positions of the particles, arising from their respective attractive qualities, as a recent writer has expressed it. Well, this is better than the old way of seeking refuge and retreat in a mere volume of dense words. It is, indeed, the only logical conclusion, this one, that the operations of the law of attraction are manifested in the motion of the particles. The great law of attraction is the greatest law in nature. It operates on all planes of life. It is always in evidence. Let us consider it. Let us begin by considering the most magnificent and constant exhibition of that law, gravitation. Gravitation is the riddle of the universe, and the one form of energy that balks science, so much a mystery that science does not even hazard a guess at its nature. No theory of the origin and nature of gravitation is to be found in the books. Let us see what gravitation is. It is more than the power that pulls things to the earth, as the average man would define it. It does more than cause water to run downhill and turn mill wheels to drive machinery. Water power results from gravitation, but even the energy of Niagara Falls is insignificant when compared to the other manifestations of the mother of energy, gravitation. Webster defines gravitation as that attraction or force by which all bodies or particles in the universe tend toward each other. Following that definition, let us add that every particle of substance has an attraction for every other particle. In view of our belief that this attraction is a form of mental effort, let us regard the term attraction as being a form of what we call desire, or even love, in the mental world. If you will think of it in this way, you will be better able to fall in with our lines of thought. And in addition to every particle of substance having an attraction, love or desire, for every other particle, it has the means and power to draw that other particle toward itself, and to move toward that other particle at the same time. Webster gives a very clear idea of this when he defines attraction as an invisible power in a body by which it draws anything to itself, the power in nature acting mutually between bodies, or ultimate particles tending to draw them together or to produce their cohesion or combination, and conversely resisting separation. The majority of persons, when thinking of gravitation, are satisfied with the idea that it is a power that pulls things down to the ground, and do not think of it as a force that pulls things other ways besides down, and which is possessed and exercised by the speck of dust as well as by the whole earth, by the molecule as well as by the mass. The reason of this is that this power is so slight in small bodies of substance that it is unnoticed, and that only when the mass is sufficiently large to make the pull strong does one perceive and appreciate that the force exists. The lack of information on the part of the average person regarding this subject is amazing, particularly when the importance of the knowledge is understood. The attraction that holds the molecules of substance together is gravitation. The attraction that pulls a piece of substance to the earth is gravitation. The action that keeps the suns and planets in their orbits is gravitation. Let us see the operations of the law. In astronomy you may learn that the movements of the planets around the sun and the moons around their planets, their regular and constant relative positions, are caused by the force of gravitation. If it were not for this attraction by the sun, the planets would fly out into space like a stone from a sling. The attraction of gravitation acts on the planets just as does the string of the whirling sling that keeps the stone from flying away during the whirling until the string is released. Some astronomers think that our sun revolves around some greater sun, and this again around a greater, and so on to infinity. If this be so, then the attraction of gravitation is that which holds them all in their orbits and places in spite of their motion. And in physics you may learn that this same attraction of gravitation prevents the people and objects on the surface of the earth from flying off into space, and that it holds the portions of the earth together, preventing them from flying apart. And remember this, for it is important: the attraction of the earth, great and powerful as it is nothing more than the combined attractive power of its constituent molecules or atoms or parts. The center of the earth is the center of the attraction because it is the center of the aggregation of its particles. It must not be supposed that the earth simply attracts downward, that is, toward its center. On the contrary, large masses of earth, large mountains for instance, exert a certain degree of attraction of gravitation, and experiments have shown that a plum is slightly deflected by reason of the proximity of a large mountain. And the reason that bodies lose weight as they descend from the surface of the earth is because they leave above them a certain large portion of the molecules composing the earth, which mass of molecules exert an attraction proportionate to their mass, which attraction balances the attraction of the mass of earth beneath them. Science teaches that if the earth were hollow in the center, the weight there would be zero, or nothing at all, and that a body would float in the space at the center of the earth, just as does a balloon in the air, the reason thereof being that the attraction would be equalized, equal attraction from every direction counterbalancing each other. Considering the earth's radius to be 4,000 miles, a body that weighed 100 pounds on the surface would weigh but 75 pounds at the depth of 1,000 miles, but 50 pounds at a depth of 2,000 miles, but 25 pounds at a depth of 3,000 miles, and nothing or zero at a depth of 4,000 miles, which would be the center of the earth. This, of course, supposes that the substance of which the earth is composed is of uniform density from surface to center. From an equal distance above the surface of the earth, bodies released or dropped will reach the surface at exactly the same degree of speed and in exactly the same time, this irrespective of weight or size. In other words, a cork or piece of lead, no matter what their sizes may be, will travel with equal rapidity. In case where the lighter substance travels more slowly, compare a feather and bullet for instance, the difference is caused by the light object meeting with more resistance from the air. The apparent exception has been explained away by the experiment of dropping the bullet and the feather in a vacuum tube, in which there is no resistance from air, the consequence being that both descended precisely at the same instant. Another similar experiment is to place the feather upon a piece of iron whereby the resistance of the air is prevented, and the feather will maintain its position during the drop, and will reach the ground resting on top of the iron, just as it started. And, remember this please, that the small object attracted by the earth exerts an attraction on its own account. If the two were of the same size they would exert an equal attracting power, but as one is similar its attracting power is very slight compared with that of the large mass. But it is true that the particle of dust attracts the earth precisely as the earth attracts the particle of dust, the difference being solely a matter of degree depending upon the mass of the body. The amount or degree of the combined attracting power is determined by the combined total of the two masses. Distance lessens the degree of attraction. Thus, as bodies are lifted above the earth, the weight decreases very gradually, and by very slight degrees, but constantly and invariably. The poles of the earth are flattened, and consequently the weight of an object slightly increases as it is carried from equator to pole. Concluding our consideration of gravitation, it will be well to call your attention to the fact that gravitation differs from the forms of radiant energy known as heat, light, electricity, and magnetism in several very important particulars, which seems to go far in the direction of proof that the latter are by incidents or consequences of the former. In the first place, gravitation, so far as is known, is not dependent upon, caused by, or maintained by any other force or form of energy. Nor does it seem to be derived from some great reservoir, from which it obtains its supply of energy. On the contrary, it seems to be a thing in itself, self-supporting, self-existing, an intrinsic thing, in fact. It does not seem to be lost to bodies by radiation, and consequently there seems to be no need of a body replenishing its supply, as there is no loss. Gravitation seems to be a constant something, remaining always with bodies and neither being lost or acquired. It exists between the atoms, molecules, masses, all in the same way. In fact, one is tempted to think of the planets and worlds in space as molecules of some greater mass held together by gravitation, just as are the molecules held together. Remember that the molecules and atoms are not in absolute contact, but there is always a space between them, although the space or distance may be insensible to us. As above, so below, says the old occult aphorism, and it seems to be so. Then again, gravitation is believed to act instantaneously, and does not require time to pass between bodies, as does light, heat, electricity, magnetism, radiant energy. Light travels through the ether as light waves at the rate of 184,000 miles a second. The same is true of heat and of electricity. But gravitation travels instantaneously. For instance, if a new star were to spring into existence at some inconceivable distance from the earth, it would require thousands of years for its light to reach us. But its attraction of gravitation would be felt instantly. Do you realize what this means? It means that gravitation is in some way connected with the ether or conveying medium, that an impulse communicated at some point of space, trillions of miles away, is felt at once at our point in space, and vice versa. There is some awful mystery here, and the laws of substance and force, as generally understood, do not account for it. And the theories regarding the ether do not throw light upon it. But wait a bit. But more than this, science holds that gravitation does not require a medium, that it seems to be its own medium, needing no ether or other medium to transmit its influence. In this respect also, gravitation differs from the form of radiant energy, and more, it is not cut off or interfered with by any intervening body, for its force operates through such intervening bodies. For instance, in an eclipse of the sun, the moon passes between the earth and the sun, but the gravitation is not affected in the slightest, for the bodies would evidence such changes immediately were it to occur. So gravitation acts instantaneously, is its own medium, and may not be interfered with by an intervening body. It, indeed, is in a different class from light, heat, and electricity. And now let us consider the other forms of attraction. In the previous chapters we saw that the form of attraction called cohesion caused the molecules to tend to each other and to remain in more or less close contact, the differing degrees of cohesion determining the density, etc., of the body. Were the attractive force of cohesion suddenly removed, the most solid bodies as well as the lightest ones would instantly fly into very fine powder, thus being resolved into their constituent molecules. The separation of the molecules, that is, the setting further apart, occasioned by heat, is spoken of by physicists as repulsion. But the writer holds that repulsion is an entirely different thing, and that the heat merely causes the molecules to lose a portion of their attractive power for each other. Until the heat being withdrawn, the molecules respond to the uninterrupted attraction. The molecules are like lovers who are attracted toward each other and remain attached unless separated violently or by some fading of attraction. Consider heat as a disturbing element, a misunderstanding between the molecular lovers, who under its influence draw somewhat apart, and are only reunited when the obstacle is removed and harmony again manifested. As we have shown you in a previous chapter, the so-called properties of matter, i.e., hardness, tenacity, malleability, ductility, etc., are simply evidence of a persistent cohesiveness of the molecules, a strong love or desire for each other that caused them to adopt every possible means in their power to resist and prevent the separation of the molecules forming the mass. It was like a desperate attempt to prevent the breaking up of the family. Each so-called special physical property of matter is seen to be but the action of the molecule resisting separation, in obedience to that law of its being called attraction, or gravitation, or cohesion, or adhesion, but which might as fitly be called desire or love. And remember that this law does not seem to be merely one of self-preservation of the molecule, for it remains intact even after the separation from its companions or family. Each so-called special physical property of matter is seen to be but the action of the molecule resisting separation, in obedience to that law of its being called attraction, or gravitation, or cohesion, or adhesion, but which might as fitly be called desire or love. And remember that this law does not seem to be merely one of self-preservation of the molecule, for it remains intact even after the separation from its companions or family. It is more, for it is a law that causes it to bend all its energies in remaining within molecular distance or close companionship with its family, and resisting disintegration. It is like the social instinct in man, if one may be pardoned from using the figure. Now for the attraction of the atoms, chemical affinity, or chemism, as it is called. An atom, you know, is the chemical unit of matter, and the smallest particle of matter that can enter into combination, leaving the corpuscle out of the consideration for the moment. These atoms exhibit and manifest an attraction for each other that causes them to form combinations or marriages, and thus to combine, forming a molecule. But remember always that when atoms combine they do not merge their identities, they simply marry and nothing more. Each atom maintains its own identity, and is found intact if the marriage is destroyed by chemical process, which might be called the termination of the molecular marriage by divorce, that is, by one atom forsaking its mate and seeking a new affinity in the shape of some more attractive or attracting atom. For alas, the atoms are more or less fickle and often leave their life partners for some other fascinating particle. At times there is manifested a condition of "How happy could I be with either, were to other fair charmer away." There is a conflict of attractions. There is more flirting and affairs of the heart in the world of atoms than in the region of the molecules, for while the latter are apt to seek only the companionship of their own family, or some nearly related family, the atoms have quite a number of possible affinities, and will invariably desert a lesser attraction for a greater one, thus forming a new molecule, and leave the deserted one to get along alone as best it may, or else form a new alliance with some other affinity who is either impervious to the attraction of the more brilliant charmer, or else is out of the danger of temptation. But, if we analyze and carefully consider this chemical affinity, chemism, we will see that it comes well under the definition of attraction, as given by Webster, and quoted in the first part of this chapter. It certainly comes under the rule of "the power in nature acting mutually between bodies or ultimate particles tending to draw them together," etc. The writer thinks that he is justified in asking you to consider gravitation, cohesion, adhesion, and chemical affinity as related forms of the same thing. If you do not like to call this same thing by the name of gravitation, suppose we call it the Law of Attraction, of which gravitation, cohesion, adhesion, chemical affinity, or chemism are but different aspects. This relation is described in Chapter 13. And the writer believes that this Law of Attraction is the underlying cause of all that we call energy, force, power, motion, etc., in the physical world. For if gravitation accounts for all mass motion, or mechanical motion, if molecular cohesion, and the vibrations accompanying it, manifest in forms of molecular motion, and if atomic chemical affinity, or chemism, manifests in atomic motion, and if even the corpuscles in their movements obey this same Law of Attraction in some form, and if all force and energy is but a mode of motion, then, if all this be true, are we not justified in claiming that this Law of Attraction is the basis of all energy, force, and motion? And are we not justified in thinking of this Law of Attraction as always manifesting in the direction of drawing together particles of Substance, be those particles suns, planets, masses, molecules, atoms, or corpuscles, in pursuance of some basic law imposed upon all things by that which is above things? The following quotation is interesting in our consideration of this subject. There are other forces besides gravity, and one of the most active of these is chemical affinity. Thus, for instance, an atom of oxygen has a very strong attraction for one of carbon, and we may compare these two atoms to the earth and a stone lodged upon the top of a house. Within certain limits this attraction is intensely powerful, so that when an atom of carbon and one of oxygen have been separated from each other, we have a species of energy of position just as truly as when a stone has been separated from the earth. Thus, by having a large quantity of oxygen and a large quantity of carbon in separate states, we are in possession of a large store of energy of position. When we allowed the stone and the earth to rush together, the energy of position was transformed into that of actual motion, and we should therefore expect something similar to happen when the separated carbon and oxygen are allowed to rush together. This takes place when we burn coal in our fires, and the primary result, as far as energy is concerned, is the production of a large amount of heat. We are, therefore, led to conjecture that heat may denote a motion of particles on the small scale, just as the rushing together of the stone and the earth denotes a motion on the large. It thus appears that we may have invisible molecular energy as well as visible mechanical energy. Balfour Stewart. To the writer it seems that the particle of Substance finds within its Mind principle, for you know we have seen that all Substance had something akin to life and mind, a constant craving, embedded in its very nature, which causes it to seek satisfaction. This craving for satisfaction results in unrest, and seeks a solution along two lines, These two lines are indicated by two entirely different desires that it finds within itself, the first being a desire or inclination to seek the companionship of some other particle, the second being a desire or inclination to be free of attachment or entanglement. The desire for attachment arises from the force of the law of attraction that exists between each particle of substance. The desire for non-attachment arises from some inward inclination for freedom. These two desires or inclinations may be called the desire for impression and the desire for expression. The desire for impression, or pressing in, manifests along lines of action tending toward attachment, moreness, companionship, combination. The desire for expression, or pressing out, manifests along the lines of action tending toward individuality, freedom, independence, unattachment, etc. And both are strong cravings, and both tend to produce unrest, which results in motion. The pull of the desire of impression exists always, and is always modified and counteracted by the push of the desire for expression. And resulting from the play of these two desires or forces result activity, motion, and change. Like the two conflicting angels in the Persian mythology, Ahriman and Ormuzd, these two desires wrestle with each other in the theater of the universe, constant motion and change being the results. And, if the writer may be pardoned for dropping into mysticism for the moment, may it not be that these conflicting desires for separateness and unity, respectively, are but different forms of the desire for satisfaction through oneness? Impression seeks oneness by combination with other separated particles, but finds it not. Expression seeks oneness by drawing apart and endeavoring to realize it in that way, but finds it not. But both are but different aspects of the same desire for satisfaction, and only when the mind recognizes oneness in diversity does satisfaction come, and thus the lesson of the particle becomes the lesson of the man. These conflicting desires of inclinations of the particles, the one urging it along the lines of attraction, the other along the lines of separation, produce the dance of the atoms, the motion of the particles. When the particle manifests along the lines of expression, it pushes itself away from the other particle and, consequently, also pushes the other particle away. When it manifests along the lines of impression, it pulls itself toward the other particle, and at the same time pulls the other particle toward itself. In both cases, the medium of the pulling extends over the space separating them, as will be described in future chapters. This pulling and pushing is called by chemistry attraction and repulsion of the particles. It is perhaps unnecessary to state that the force of the attraction of cohesion or of chemical affinity is much stronger than that of gravitation in the case of the same particles. Otherwise, if one picked up a piece of iron, the attraction of gravitation would cause its particles to separate and fall to the ground, whereas the attraction of cohesion and that of chemical affinity enable the particles to counteract the pull of gravitation and thus remain intact. Compared with cohesion or chemical affinity, the pull of gravitation is incomparably weak. The force which holds together two atoms of water represents a high degree of dynamic power, and the shock of forcible separation of chemical atoms produces something akin to an explosion. So we see that the attraction of the particles, while of the same nature as gravitation, is much higher in intensity. But notwithstanding the power of the attraction, it seems to be a matter inherent in the nature of the particle, and to represent a something like will in response to desire. The varying push and pull, or the two desires, would necessarily cause a revolution of each particle on its own axis, and a revolution around each other, besides many instances of rushing together and away from each other. In these forms of motion is to be found the cause of the vibrations producing radiant energy known as light, heat, electricity, and magnetism. End of Chapter 10.
Chapter Dynamic Thought, or the Law of Vibrant Energy, by William Walter Atkinson. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. Chapter 11. The Theory of Dynamic Thought. From the preceding chapters we have learned that 1. The forms of force or radiant energy known as light, heat, magnetism, and electricity are modes of motion, arising from the original motion of the particles of substance, molecules, atoms, corpuscles, or electrons, and that such original motions of the particles arises from the operation of the law of attraction. 2. That the forms of attractive force or energy known as gravitation, cohesion, adhesion, atomic attraction, chemical affinity or chemism, and corpuscular attraction also arise from the operation of the law of attraction. 3. That from the above it follows that all manifestations of force and energy in inorganic substance, viz., both radiant energy in its forms of light, heat, magnetism, electricity, etc., and also attractive energy in its forms of gravitation, cohesion, adhesion, chemical affinity or atomic attraction, and corpuscular attraction, arise from the operation of the law of attraction. It will be well to remember that the fact that some of the above forms of radiant force or energy, such as heat, light, magnetism, and electricity, may arise from motion transmitted from other substance, does not alter the matter. For if they arise from waves from some other substance, it merely follows that the original motion that gave rise to the waves arose from the operation of the law of attraction. Or if they arise from interrupted motion, it merely follows that the motion that is interrupted may be traced back to original motion that arose from the operation of the law of attraction. So that all mechanical power, and all the forms of energy or force producing the same, omitting for the moment the forms of energy or force of living organisms which will be described later on, arise from the operation of the law of attraction. Now for the next step. We have seen that the operation of the law of attraction results from vital mental action on the part of the life and mind principle inherent in the nature of the particles of substance. Consequently, all forms of energy and force arising from the operation of the law of attraction, the latter being the result of vital mental action, then it follows that all forms of energy and force having its origin in the law of attraction are manifestations of vital mental action. But this is not all, for we have not considered the energy and force abiding in and manifested by what are called living organisms, such as human, animal, and plant life, which are manifested by the physical organisms or bodies of man, animal, and plant. In order to avoid a long digression into the realms of biology, we will omit all but a passing reference to the theories that seek to identify the action of the cells of organic life with those of the particles of inorganic life. For remember that organic substance has its molecules, atoms, and corpuscles, as well as its higher combinations known as cells, and we will seek the ultimate source of all forms of force and energy exhibited by organic life in that which lies back of physical action. We need no argument here, for all will readily recognize that behind the physical action of man, animal, and plant lies life and mind, and that therefore all force and energy arising from such action must be manifestations of vital mental action. And so, summing up our conclusions regarding force and energy and motion and then in organic substance, we arrive at an understanding of the basic proposition of the theory of dynamic thought, which is as follows. Basic proposition: that all forms and exhibition of force, energy, motion, and power are manifestations of vital mental action, and that consequently at the last there is no force but vital mental force, no energy but vital mental energy, no motion but vital mental motion, no power but vital mental power. It is possible that the average reader will fail to recognize the tremendous importance of the above proposition. It is most revolutionary, and is not only directly opposed to the materialistic theory which makes matter the dominant factor, the only factor, in fact, in life, but it is also far different from the opinion of the average person who has been taught to think of blind force, dead matter, mechanical energy, power of machinery, engines, etc. And yet you are invited to go back over the path that leads up to the theory and test and examine every bit of the road for weak spots, insecure bridges, etc. The writer feels that the work will bear examination. He thinks that he has succeeded not only in proving that 1. The universe is alive and thinking, and 2. That mind is dominant, but he believes also that he has made at least partially understandable the old occult and metaphysical aphorism that has been heard so much in these later days, the statement that All is mind. Mind is all. The only fact needed now is proof of the old occult theory that matter or substance blends gradually into mind, and that in the end is found to have its origin there. So far science has not given us this proof, but it begins to look that way, although science does not dream of what lies at the end of the road she is traveling. She tells us that she sees matter melting into force or energy, and that perhaps the universe may be found to be energy or force at the last. But she ignores the fact that her investigations have already proven, to those who know how to combine them, that mind is back of force, that all force is mental force at the last. And so, you see, it is not so far a cry from matter to mind in these days of the 20th century. The bridge is being erected by the materialists, but the mentalist will be the first to cross over it. But there are many important questions ahead of us for consideration in relation to the theory of dynamic thought, and we must hasten on to them. One of the first questions that must be considered is that of the transmission of force, energy, or motion. Science has told us that light travels and is contagious, that heat travels and is contagious, that electricity travels and is contagious, that magnetism travels and is contagious, but it has failed to find evidences of cohesive force or adhesive force, or the force of gravitation, or the force of chemical affinity, or the force of corpuscular affinity being contagious. And although it recognizes that they must travel beyond the limits of the bodies manifesting them, yet it has hazarded no theory or hypothesis worthy of the name to account for the phenomenon. It informs us that light, heat, magnetism, and electricity travel via waves of the ether at the rate of 184,000 miles per second, and that when they reach their destination the ether waves set up similar vibrations in the substance with which they come in contact. The only explanation of the method or medium of travel is the Aristotle's ether theory, which, while generally accepted as a working hypothesis, nevertheless brings a broad smile to the face of any thoughtful scientist who considers it in detail. As for the medium of the transmission of gravitation, cohesion, chemical affinity, and molecular affinity, science is mute. All that she says is that gravitation is believed to travel instantaneously over distances that it takes light traveling at the rate of 184,000 miles per second over 2,000 years to travel. Verily, gravitation defies scientific theories and estimates and laughs at the ether. Let us see if the dynamic thought theory throws any light on the subject. The first step in the solution of the problem of the transferring and communication of energy is the remembrance of the fact that the energy is purely mental. Be it gravitation, affinity, or attraction on the one hand, or light, heat, magnetism, or electricity on the other, it is all mental force. Attraction in all of its forms has been recognized as mental action, and the vibrations that cause light, heat, magnetism, and electricity have been seen to result from the law of attraction, and therefore are mental. This being the case, would it not be wise for us to look for a solution of the transmission of force and energy in the region from which it originated, the mental region? Does not this seem reasonable? Should not the explanation for mental effects be sought in a mental cause? And should not the medium between mind and mind be looked for in the mental region? Taking the liberty of peeping into some of the succeeding chapters of this book, getting a little ahead of the story, as it were, let us consider the operation of mind in the higher forms of life. Without argument or proof at this point, let us remember the well-founded statements of fact, and the old occult teachings as well, that the mind is not confined to the limits of the body, but extends as an aura for some distance beyond its physical form. Let us also remember that the phenomena grouped together under the general subject of thought transference, thought transmission, telepathy, or the best term of all, telesthesia, meaning literally far-off sensation. The writer imagines that he hears the yell of derision go up at this point from the materialistic personage or the man on the street who has been induced to read this book by some well-meaning friend. Thought transference, fiddlesticks, we may hear him cry in imagination. But let this reader remember, fiddlesticks or no fiddlesticks, that thought transmission is a proven fact, and that thousands of people know it to be so absolutely from their own experience. It is too late in the day for sneers at the mention of the term. Well then, since force is mental, and we are looking for a mental explanation for the phenomenon of transmission of force, does it not seem natural to consider thought transmission in that connection? Answering a possible objection of some critical reader to the effect that before a sensation may be received the receiver must have sense organs, a very good objection, but one that is answered by science itself, let us read on. Haeckel, the distinguished scientist, in his endeavor to prove that man's senses are but a development of something in inorganic life, has called our attention to the fact that molecules and atoms are capable of receiving sensations and responding thereto. He makes quite a point of this in his latest works, and remarks, among many other things, showing his positive view on the subject of sensation in the inorganic world. I cannot imagine the simplest chemical and physical process without attributing the movements of the material particles to unconscious sensation. And again, the idea of chemical affinity consists in the fact that the various chemical elements perceive the qualitative differences in other elements, experience pleasure or revulsion at contact with them, and execute specific movements on this ground. He also quotes approvingly the remarks of Nageli, who said, "If the molecules possess something that is related, however distantly, to sensation, it must be comfortable to be able to follow their attractions and repulsions, uncomfortable when they are forced to do otherwise." Haeckel also says that in his opinion the sensations in animal and plant life are connected by a long series of evolutionary stages with the simpler forms of sensation that we find in the inorganic elements, and that reveal themselves in chemical affinity. Is not this strong enough? Perhaps we may now be permitted at least to assume that even the atoms, molecules, and corpuscles have something like sensation. Someone may now object that Haeckel speaks of contact between the particles, and that sensation by contact even in an atom is far different from the sensation without contact at a short distance. Quite right. But if the objector will take the trouble to review the teaching of science regarding the relation of the particles, he will see that the particles are never exactly in contact except in moments of collision, which, by the way, they carefully avoid. The corpuscles, as we have shown, have plenty of room in which to move about, but they move in orbits around each other. The atoms combine, but there is always room between them, as may be seen by reference to the teachings regarding the ether, which fills up the cracks according to the theory. And the molecules also have plenty of room, as may be seen by reference to that part of the subject, particularly to the comparison of the drop of water magnified to the size of the earth, in which the molecules would appear about the size of the original drop, with more room between each than their own size. In fact, as we have been shown in a previous chapter, the particles are attracted only to a certain distance, at which they resist the impulse or attraction and stand off a bit. They will not be forced too near without creating disturbances and manifestations of force, and if they are separate beyond a certain distance the attractive power ceases to operate. But there is always some room between them, and they bridge over that room and exert and receive the attractive power in some way. This is true not only of the particles, but of the great bodies, like the earth and planets, that are attracted and attract over great distances. Now for the question: how do they exert sense and attractive power over the great comparative distance, great comparatively as well in atom as in planet and sun? Someone may answer the question closing the last paragraph with the word electricity. Very good. Electricity, like the ether, comes in quite handy when one is forced to explain something not known. Electricity, like the glacial period, Aristotle's ether, natural laws, and suggestion, is a most handy weapon of argument, and often acts as a preventive to further inquiry and investigation until some sufficiently irreverent of precedent arises to ask, "But why and how?" and starts the ball rolling again. But electricity will not answer in this case, for the rate of the travel of electricity is well known, 184,000 miles per second, which, fast as it is, assumes the crawl of a slow freight when compared with the instantaneous rate of travel of gravitation. And then electricity requires a medium and gravitation does not, and in many other ways the two are seen to be totally different. And in the case of the space between the atom and molecule and corpuscle, it is no more reasonable to say electricity than it would be to say heat or light, and magnetism is not available for obvious reasons. Remember that electricity, light, and heat are caused by motion resulting from attraction, and the child cannot procreate the parent. Heat, light, and electricity may beget each other, and they do, and gravitation may procreate heat, light, and electricity, but heat, light, and electricity cannot procreate gravitation, never, and light, heat, and electricity require replenishing from the common source of energy, but gravitation is self-sufficient and asks no replenishing or storage battery or powerhouse. Electricity, heat, and light come and go, appearing, manifesting, and disappearing, swallowed up by each other or by substance, but gravitation is always there, unchangeable, unwavering, immutable, invariable, something above matter and force, something majestic, awe-inspiring, sublime? Does it take a wild flight of the imagination to see that this something that is not matter and not force must be a manifestation of mind? Let us first apply this idea of thought transference to the operation of the law of attraction between the corpuscles, atoms, and molecules of substance, particles of substance. Particles are believed to move to or away from each other in accordance with the workings of attraction and affinity in its varying degrees. First, they must desire to move. Not desire in the developed sense that we feel it, but still elementary feeling or inclination or tendency, call it what you will. But it remains rudimentary mental emotion, an E-motion, leading to motion. This is not a pun. Look up the meaning of the word emotion and you will see its application. Then following the desire comes the action in the direction of gratifying it. The particles act to gratify desire in two ways. Acting at a distance, remember, they exert the attractive force which the writer believes to be mental force transmitted by mind, projection, a mental or psychic bond or connection being thus established. By means of this bond of mind the particle endeavors to 1. Draw itself to the object, and 2. To draw the object toward itself. In the case of the molecule, this desire and movement seems to be mutual and evidenced by and to all molecules alike, providing they be within molecular distance, as science calls it. But in the case of the atoms it seems to be different, for there is found a greater degree of choice or elective affinity. This election or choice is not altogether free, but depends upon the relative likes and dislikes of certain kinds of elements, as we have seen in previous chapters, although to be sure these elements are all made out of the same stuff in different combinations. The details of corpuscular attraction are not known, so it cannot be told whether preferences exist, or whether, in the words of the street, all corpuscles look alike to each other. It would appear, however, that there must be some reasons for preference among the corpuscles, else they would always form in the same combinations, always act alike to each other as they are alike in other actions, and thus there would be but one element or kind of atom formed instead of the 75 already known. To be sure, in this case it might be that the one kind of atom formed would be the atom of hydrogen, and that all other elements or atoms were modifications of that one, just proving the dream of the scientist of the 19th century. But as Kipling would say, that is another story. To return to the particle which we left trying to draw the other particle to itself and itself toward the other, there is no material connection between them, and electricity and magnetism will not answer, so what is to be done? Evidently the particle knows, for it exerts a drawing power or force by means of the mental connection, and the two come together. The particle evidently is able to exert a repelling or moving away power by reversing the process, the mental bond acting as the medium. This may cause a smile because we have never seen an instance of bodies pulling themselves together by intangible bonds. Haven't we? Then how about two pieces of magnetized steel or two electrified substances? Oh, that's different, you say. Why different? Isn't the bond intangible? And haven't we seen that both electricity and magnetism were mental actions also? Yes, that's it. Perhaps the attracting force is magnetism or electricity. No, that will not do, for we have seen that electricity and magnetism were products of this attraction, not producers of it. The attraction must come before electricity and magnetism, not after them. You are mixing cause and effect. And even if you were right, and you cannot be, wouldn't the electrical or magnetic force be called into operation and directed by the mental action arising from the desire? You cannot get away from mental action when you study the law of attraction. But how about the fact that the heat causes particles to change their vibrations and draw apart, and all that sort of thing, and electricity likewise, you may ask? Surely this takes the matter away from mental action, doesn't it? Well, the writer thinks that the phenomenon referred to only helps prove his theory, and he will endeavor to so prove to you. The consideration of the facts related in this chapter leads us to a supplemental proposition to our basic proposition, which may be stated as follows. Supplemental Proposition 1. Not only is the law of attraction the manifestation of a mental process or vital mental action, but also the actual force or energy used in bringing the particles of substance in closer relation in accordance with that law is in its nature a vital mental force or energy, operating between bodies or particles of substance without a material medium. End of Chapter 11. Recording by Philip Gould.